All right, homework 2. Got to use a calculator. Talking about rates. We can think of a rate as a derivative. When you take an antiderivative of a rate, you'll get a total. You can't take the antiderivative, but you can find the area under the rate using our calculator. I can find the integral from A to B of, let's say, a rate n. This would give me a total amount that have flowed in from A to B. Given E is the rate at which something is being added, L is the rate at which something is leaving, and given an initial amount of, say, 50, write an expression for the total amount at a given time. You could say my total amount at a specific time, and this is a total, is equal to an initial amount. In this case, my initial amount is 50, plus the total amount that has been added, total amount in, minus the total amount out. Well, the total added will be an integral from my initial time, which is 0, to whatever my time is, of E, and my total out would be an integral from 0 to t of L. Now, what we could do if we wanted to, and this is the property of integrals we're going to talk about in the future, is combine these to just be one integral. Now, if you watch the video of the lesson, it's done like this. I think I'm going to update the video, and I'm going to have this as my what I'm going to go with for the rest of the problems in our notes, is this total initial amount plus our total added minus our total that has been removed. All right, how do we know when we're adding more than we're removing? Vice versa, I can find when a total is a max or a min. We always look at derivatives, okay? We would probably do a derivative sign analysis, okay? Don't forget about our friend that we've done in the past. Now, what's important is that t prime, the derivative of this t, the initial amount is gone. The derivative of this integral would be e. The derivative of this integral would just be L, or the derivative of this is E minus L. So E minus L, we could graph, and we could find when is our total increasing. If this is positive, T prime positive, my total amount's increasing. T prime negative, my total amount's decreasing. That's it. It's the same stuff that we've done before, only just with little different context, okay? All right, let's get into it. We got fish entering. This would be our rate in, or the rate being added. Fish are leaving. This would be our rate out. We are not told an initial amount. Maybe you're going to be told an initial amount in one of the parts, but for right now, we're just say you got 0 fish in the tank to start with, okay? All right, how many fish enter the lake over a 5-hour period from 0 to 5? Give your answer to the nearest whole number. Well, we're just talking about the total in. The total in would be an integral of our rate in. We're doing our total in from 0 to 5. So it would be the integral of our rate in from 0 to 5. So in my calculator, 0 to 5 of E. Let's go ahead and do those calculations. Now, I think a lot of students have problems with typing things incorrectly. So if you got yourselves the old nice new calculator, let's go ahead and use that because it will be nicer to be able to see. So we're going to go math 9, integral from 0 to 5 of my rate in 20 plus 15 sine pi over 6, or pi t over 6. Actually could take the antiderivative of this, but who cares? Let's just go with this, and I get 153 fish. Okay. Part B. Oh, gosh. I can't believe that just happened. Let's see if it saves. Yeah, it's blank. Great. All right, whatever. I'll have to just add that to the video.
I can find a number.
$153 fish. Part B. What is the average number of fish to leave the tank over the hour over a 5-hour period? I need to find the average. So if I look at L is the rate at which they left. It's not the total amount left. This is a tricky question. Oh, okay, hold on. Sorry. It's what is the average number of fish that leave the tank, that leave the lake per hour? So we are talking about the average rate out. How do you find the average of something? 1 over b minus a, integral from a to b of what we're trying to find the average of. We would do these calculations in our calculator. 1 over b minus a, integral from a to b of what we're trying to find the average of, which is 4 plus 2 to the 0.1 t squared. $6.059 would be the average rate out. Part C, at which time is the greatest number of fish in the lake? Okay, so I'm going to first talk about the total. Total will be an integral from 0 to t of my rate in minus an integral from 0 to t of my rate out. The derivative of our total there is the rate in minus the rate out. Max t will be when t prime changes sign from positive to negative, which is a relative max, or an endpoint. So we need to graph t prime. I think those are mine. So let's go into our calculator. Y equals, let's graph E minus L. Make sure you use parentheses. We're going from 0 to 5. Just my window 0 to 5. Also graph y equals 0 to find the intersection. I'm confused why it doesn't cross. I'm assuming that things are going to be crossing. Everything looks good. 20 plus 15 sine pi x over 6 minus 4 plus 2 to the 0.1 t squared. What values am I getting? It's all positive. It's coming down. There it is. It's negative. Oh, gosh, Mr. Messner. The window's from 0 to 8. My bad, guys. So it's positive. There you go. Second calc intersect. Second calc intersect. Enter, enter, enter. Here we go. Here's my friend. The sine analysis of T prime. T prime is positive until 6.203. Negative after 6.203. That is telling me T on my interval is going up, then going down, and it's strictly going on the interval. What is the number of fish greatest? T equals 6.203 must be when the total is a max, as T prime is positive for T's less than 6.203, and T prime is negative for T's between 6.203 and 8. Part D. All right, the rate of change in the number of fish increasing or decreasing at T equals 5. So the way they word this is tricky, and they do this more, and this is one of the more recent years. The rate of change increasing or decreasing. It's not, is the rate of change, it's not asking you, is the number of fish increasing or decreasing? Okay, that's very important. It's not, is the total increasing or decreasing? That's not what they're asking. They're asking, is the rate of change increasing or decreasing? So this is very important, and this is very tricky. So is the rate of change increasing or decreasing? Well, how do you tell if something's increasing or decreasing? You look at the derivative. It is asking you, is the rate of change, is its derivative positive or negative? That's tricky. So we need T double prime of 3. Was it 3 or was it 5? 5. So T double prime of 5. I'm going to have to take the derivative of T prime at 5. T prime is E minus L. So I'm going to have to go in my calculator. I have E minus L already graphed, which is nice. I'm going to second calc the derivative at 5. And I get negative 10.722. Which means the rate of change is decreasing. T double prime is negative. Tricky. All right, next one, escalator. We got people getting in line for an escalator, then people will be exiting the escalator at this. So this is my rate in. This is my rate out. 20 people in line at time 0. That's my initial amount. How many people enter the line from 0 to 300? So total in. It's not the total amount, just the total that has come in. That's going to be an integral of my rate in from 0 to 300. That's going to be the integral from 0 to 300 of R. So, math, 9, 0 to 300 of 44 times T over 100 cubed. Many of you need to practice typing stuff into your calculator because you stink at it. And if you're just like copying things off the key, you're actually not going through the process of making sure you have parentheses, making sure you're taking things to the correct powers, plugging in integrals, all that stuff. Okay? You get 270. That's nice. During the time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at t equals 300? Okay, the total at 300 will be our initial 20 plus our total in. We already found. I'll write it. Integral of my rate in minus my total out. Total out would be just 0.7 times 300. It's easy enough to find. So just 0.7 times the time at which it's consistent. It's like velocity, it's like distance if your velocity is constant. So I got 20 points plus 270 minus, just to show you, this is just going to be 300 times 0.7. So 300 times 0.7, 210, 210, 60 plus 20, 80. Okay, so 80. Nice numbers there. Part C, when is the first time there are no people in line for the escalator? Okay, so I got 80 people in line, which is my my initial amount. I'm seeing when my total is 0. I got 80 people in line. No more people are being added. I know no more people are being added because after 300 seconds there's 0. And then I'm taking out from 300 to some time 0.7. Now, it's really just this simple equation. 0 equals 80 plus, I mean, you can find just 0.7t and find t, but then add it to 300. Like the antiderivative of this is 0.7x from 300 to t, so this would be 0.7t, and then minus, and I'm subtracting this. I hope you guys did this different ways. I hope this isn't confusing you. Using your calculator. 80 minus I'm subtracting. Sorry. Okay. That's 80 plus. That's 290. Negative 290 divided by negative 0.7 is 414.285 seconds. Or what's simple is just 0 equals 80, or really 80 equals 0.7 t. So how long will it take to get that? You got 114. That is the amount of seconds to get rid of 80 people if there's nobody entering. Take that and add 300 to get your time. All right. Part D. See it very often. When is the people in the line at a minimum? Find the number of people in line at that time. People will be in a line min when t prime either changes sign from negative to positive or an endpoint. We could exclude some endpoints if we do a good analysis. Go ahead and graph t prime. T prime, we've already talked about, is rate in minus rate out. So this would be R minus 0.7. So I'm going to graph R minus 0.7. $44 t over 100 cubed times 1 minus t over 300 to the 7th minus 0.7. We're looking from 0 to 300. Okay, we got some stuff here. So we got t prime value that is going to be negative until $33.013, and positive until 166.574. Unfortunately, I need to kind of check, make sure these values are perfect, because I'm not using them in my answers just yet. 33.013298. Okay, so that's telling me t is going down, going up, going down. T of 0, not max, because t prime is negative from 0 to 33.013298. So, oops, this is not the min. The candidates, therefore, are this and here at 300. So I got to find the candidates and their values and compare them. We talked about this last unit. We're doing it more this unit, so I hope we understand what we're doing. All right, I have my initial amount 20 plus the rate in R, and then go ahead and just like minus the L. It's the same thing as if you did the rate out subtracting. But whatever. Find that value. I think I did some work with that in the past, right? Okay, so save that. $20 plus integral from 0 to 33.013298 of that minus integral from 0 to 33.013298 of L. You could have just done 0.7 times that value, and I get 3.803. Well, that must be increasing a lot. Huh. I guess it's the fact that this interval is so long. This area is so much greater than this area. The area would be the total amount that I've added. And just as an approximation, the total amount that I added would be that. It's like 154 people. Let's find the area between here to 300. This is just an approximation. That's only 77. So I had 80 people. I added 150 people. I started with 20. I lost some people. Then I added a lot of people. Then I lost some people. But yeah, that makes sense. So this is definitely the min. My candidate was this value as well as this value. I already found this value from part A. It was 80. So min is T equals 33.013 by the candidates test. Okay, you could have also like just found T of 0, which is 20, and then just compare the three values. Let's even get one more question in. So we did this during class, so I'll just do it quickly again. It does involve some time to plug stuff in. How many feet of cubic feet of rainwater flow into the pipe? Well, let's read. We got the rate at which rainwater flows into a drain pipe is R, so this is my rate in. Rate at which it's flowing out, since it is partially blocked, is that. That's my rate out. And my initial amount is 30. All important. I'm only asking for the amount of water that has come in. Well, that's going to be the integral from 0 to 8 of my rate in R of T dt. So just using this 0 to 8 of R I get my total in is 76.570. It would be in cubic feet total. Part B is the amount of water in the pipe increasing or decreasing at T equals 3 hours. Give a reason for your answer. Okay, well, my total water in the pipe will be equal to my initial amount plus my total in minus my total out. My initial amount was 30. My total in is going to be an integral from 0 to t of my rate in. My total out would be an integral from 0 to t of my rate out d. I'm going to call this t of t. Okay? Well, is the total amount increasing or decreasing? We'll look at the derivative. T prime, the derivative of 30 is 0. The derivative of this integral is r. The derivative of this integral is d. So let's find t prime of 3. If it's positive or increasing, if it's negative or decreasing, right? T sign of t prime tells us if t is going to increase or decrease. So r minus d at 3. I think I'm going to need r minus d in the future to find maximum min, so let's just graph it. 20 sine t squared over 35 minus, use parentheses when you subtract d, negative 0.04 t cubed plus 0.4 t squared plus 0.96 t. Graph, oh geez, window 0 to 8. I'm looking at 3. I get negative 0.313. Total is decreasing because its derivative is negative. Part C, at which time is the water in the pipe at a minimum? Justify your answer. Total will be a min when t prime changes sign from negative to positive, or an endpoint. I already graphed t prime, that's great. I see it goes negatives to positives, actually. So I know, but I have to justify, it's got to be at this location where we intersect. Second calc intersect, enter, enter, enter. This is my sign chart analysis for t prime. Now I can't just use this for my justification. I have to explain this. But I see it's negatives until 3.271. I don't have to find the actual amount of water, so this is good. 3.271, and then it's positive after that. That means t is decreasing then increasing. I already found t of 3 was decreasing. So since t prime is negative from 0 to 3.271, and t prime is strictly positive from 3.271 to 8, is it 8? Yep. T equals 3.271 must be the min, must be when the total is a min. Don't have to check the endpoints, right? I don't have to check the endpoints because I know for a fact values are decreasing then increasing by looking at the derivatives. D. Pipe can hold 50 cubic feet of water before overflowing. For t equals 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Right, but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. Well, pipe's going to overflow when the total is greater than or equal to 50. So I need to figure out when the total is 50. Well, when does my initial amount, 30, plus my total in, this is from 0 to w of r, minus my total out, equal 50. This is something that I can find. When does total water at a specific time W equal 50? You might be thinking you start at 8 and go to W. If you start at 8, you need your total water at 8. You don't have to find your total water at 8. You don't have to find your total water at all. So that's your work right there. All right, I got to pause there and finish the remaining 3 problems tomorrow morning. All right, continuing on. Next problem, we got a rate at which unprocessed gravel arrives at a gravel processing plant is capital G. This capital G is our rate at which it's arriving, so that's our rate that things are coming in. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. There's my initial amount. And during the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. That's the rate out. Find G prime of 5 using correct units. Interpret your answer in the context of the problem. Okay, so I'm going to use, and this is all you need to write, math 8 to find the derivative with respect to x of G to find G prime. Now, what's really going to be confusing is our answer. I get negative 24.587. Now, a derivative is a rate of change. G is the rate. G prime, therefore, would be the rate of change of G. Rate of change is G would be the rate of change of the rate at which gravel, unprocessed gravel, arrives. The units, you know, it's like the rate G of T is already in tons per hour. If I take the derivative of this with respect to T, you end up with tons per hour squared. It's like an acceleration. So that would be the correct units. That's confusing because usually people answer the rate at which unprocessed gravel is arriving, but that would be G of 5. G of 5 would be the rate at which unprocessed gravel arrives. G prime would be the rate of change of the rate. It would be like the acceleration of the gravel. B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. We are operating over 8 hours. We'll go over, again, our total will equal an initial amount plus a total amount that has come in minus a total amount that has gone out. So I'll say T of T, and we'll use, T of T is our initial amount, which is T of 0, which is 500, plus the total in would be integral from 0 to T of our rate in, and then our total out would be the integral from 0 to T of our rate out. You could have G minus 500 in one integral if you'd like. So T of 8 would be 500. Starting with that, then I have this much coming in from G, coming in, and then I have this much going out or being processed. Using our calculator, we will get 500 plus integral 0 to 8 of 90 plus 45 cosine t squared over 18. You're not plugging in 8 for this. You're plugging in t. dt minus integral, and I could just put the minus in here as well, but I like to just do separate integrals for simplicity. Oh. I mean, this doesn't make any sense, actually. But that's not what they're asking us to find, actually. Oh, my bad. Let me just make sure really quick. This is in radian mode. It means like we're going to lose gravel. Oh, did I type in 500? 100. All right. That's not the question, though. I'll use this in the future. Got to make sure we're careful here.
I was wondering, I have a physics test I have to take. Could I borrow a calculator?
So the answer would be 525, but that's not the question. I'm sorry. This is the second time in a row, or second time in this homework key that I've just not read the question carefully. Read your questions carefully, people. Total amount of processed gravel that arrives. I need to find the total in. That's it. That arrives. Read the question carefully. Total in would be the integral from 0 to 8 of your rate in sure. We'll write rate in, which will be integral from 0 to 8 of g, which is integral from 0 to 8 of g. 90 plus 45 cosine t squared over 18. Close parentheses for the cosine dt. 825.551 tons. Cool. C is the amount of unprocessed gravel of the plant increasing or decreasing at time t equals 5 hours for the work that leads to your answer. All right, so let's go back to talking about the total. Total would be our initial plus integral of our rate in minus integral of our rate out from 0 to t. I'll make sure it's very clear for initial total that's come in minus the total that's gone out. So T of t would be our initial plus our total in minus our total out. Okay. The reason why I do this is because to find if something is increasing or decreasing, and this is the amount of unprocessed gravel, is it increasing or decreasing, we need to look at the derivative of the total, t prime. We will see if t prime is positive or negative. Well, if I took the derivative of this, the derivative of 500, 0, the derivative of this accumulation function will just be g. The derivative of this will just be 100. So t prime is g minus 100. If, and I might as well graph g minus 100, but if it is positive, that means the total is increasing. If it's negative, the total is decreasing. Let's go ahead and graph this because we're going to use this graph in the next part when we're finding a max or a min. Minus 100. I don't have to use parentheses because I'm just subtracting 100. I'm also going to graph y equals 0. I'll need that in the future. My window is from 0 to 8. Okay, and I'm looking at 5. T prime of 5 is negative 1.859. Therefore, the total unprocessed gravel is decreasing. We have more processing done than gravel arriving. And your reasoning is because the derivative T prime is negative. To part D. What is the maximum amount of unprocessed gravel at the plant during the hours of operations on the workday? Max. We already talked about T, so this is going to be used. T is going to be a max, either at a relative max, when T prime goes from positive to negative, or an endpoint. Now, I did an analysis right here of the signs. It looks like it's positive and then negative. Let's adjust this to be like negative 50 to 50. Beautiful. So T prime is positive and negative. That means the amount of gravel will be increasing than decreasing. And it changes signs at this 0. Find the 0, 4.923. I know for a fact that must be the location of an absolute max. Let's see, do they ask to find? They want to find the maximum amount. Okay, so I need the entire decimal because I'm going to use it. 4.923. 4803. I know that's a max. I'll justify it in a second. That's going to be equal to our initial amount plus our total in minus our total out. I'll do the calculations. Did it earlier, just with a different value. So 500, 02, 4.9234803. I found the total amount at the other endpoint. I know that's going to be less, 525. It's going to be less than this value. Just guaranteed because I've done an analysis of the signs of my derivative. I see this will be greater, 635.37. That's the 373 decimal places. 6. This is in tons. This is the max amount. Since T prime is strictly positive from 0 to 4.923, and T prime is strictly negative from 4.923 to 8. Okay, I don't say it's because the signs change. If I say that the signs change, then I might not be talking about how the signs are consistent. They are positive, then they are negative. This must be the max if we're talking about an interval from 0 to 8. Okay, and I found the maximum amount. I do not have to find the endpoint. So I just exclude that. This confirms that it's definitely not at an endpoint. It's definitely going to be this. All right. Next question. There's no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate of that. Okay, so this would be like the rate at which snow is being added, or the rate in. Janet starts removing snow at 6 a.m. T equals 6, at a rate in cubic feet per hour. The rate at which Janet removes the snow is this. So that's a rate out. Now the rate out is going to be different depending on the hours. How many feet of snow is accumulated on the driveway by 6 a.m. So I need the total in. Most of our questions ask just for like part of a total amount, so just the total in. That'll be an integral from 0 to 6 of our rate in. So that'll be an integral from 0 to 6 of f. Using my calculator, math 9, integral from 0 to 6 of 7t cosine, nope, 7te to the cosine t. $142.274 cubic feet. Part B, find the rate of change of the volume snow in the driveway at 8 a.m. Okay, so total of snow, initial amount 0, plus integral of our rate in minus integral of our rate out. Rate of change would be t prime. That will just be the rate in minus the rate out. That's going to be f minus g. At 8, we'd have f of 8 minus g of 8. F of 8 I can find using my calculator, 7 times 8 e to the cosine 8 minus g of 8, I will be using 108. Janet obviously slows down in her removal of snow. She starts hard, slows down for the last 2 hours. We get negative 59.583. Come on, I usually truncate. So 582 cubic feet per hour. Not hour squared, hour. Okay. So that'd be the rate of change. C, let's read the question carefully. Let H represent the total amount of snow in cubic feet that Janet has removed from the driveway. Express H as a piecewise defined function with the domain 0 to 9. Well, if H is the total, H of t would be the integral of g of t. Now, you got different situations. You got 0 from 0 to 6. That's not going to change. Now, it would be the integral of 125 would be 125t, but from 6 to 7. So to adjust that, so it's like 125 over an hour, we'd have to take that time and subtract 6. So that's like in the 7th hour, I would total 125 cubic feet removed. In the 6th hour, I'm still at 0. That's a little bit tricky to kind of figure out. You know, you don't see this question too often. And then you'd have 108, but it'd be t minus 7. Here's another way to get that. Let's do it down here. So H is going to be the integral from 0 to t of g of t. Okay. So I got the integrals of all of these. Just so that you're not like figuring it out, you can just kind of find it. So the integral from 0 to t of 0 dt equals 0. Antiderivative of 0 is just a constant, but the constant, when you find the change between 0 and t, would just be 0. So I got 0 from 0 to 6. Integral from 0 to t of 125. Does this work? Or do I need to change it from 6? Let's see. Get 125 from 0 to t equals 125t, but that's not right. It's going to be from 0. This is going to be from 6 to my time. Okay, that's going to work. So from 6 to t, watch how this will work out. Okay, so this would be 125t minus 125 times 6. That ends up being 125 times t minus 6. So that's like how you can get that equation without having to figure it out. And this is going to be from 6 to 7. And then the final one would be the integral from 7 to t of 108. So that'd be 108. I don't want to say, let's use x, because it's 125x. This would be 108x from 7 to t, which would be 108t minus 108 times 7, which is 108t minus 7. So that just kind of adjusts it so that if you're plugging in 9, you're going to have 2 hours at 108 per hour. I hope that might make more sense than just trying to figure it out. You could just go straight to this and figure it out. This can only be done if your rate is constant like this. Anyways, part D, how many cubic feet are on the snow on the driveway at 9 a.m.? I'd probably say, our total initial rate in, rate out. Our initial amount was 0. I got snow accumulating, and this is going to 9 a.m. of F. I'm going to subtract 6 to 7 of 125. That would be one of my rates out. And I'm also going to subtract from 7 to 9, 108. You could use this, you can use just your understanding at, it's like your total of snow that's fallen minus 125, which has been removed after an hour, minus 108 times 2, which has been removed for 2 hours. Like different ways to find our total at 9 a.m. is going to be math 9. This is this from 0 to 9 minus 125 minus 108 times 2. 26.334 cubic feet. So she's almost done. All right. All right, we got water going in a storage tank. Rate at which water enters the tank is F, so this is another rate in. Rate at which water leaves the tank is different. It's another one of these constants. This is my rate out. The graphs of F and G, which intersect at 1.617 and 5.076. That's nice that they gave you that. Since they gave you those values, you don't have to round or find them and round. At time t equals 0, the amount of water in the tank is 5,000 gallons. There's my initial amount. How many gallons of water enter the tank from 0 to 7? So again, this is another question where it's just the total in. Total in would be integral from 0 to 7 of my rate in. That'll give us the total in, which will be 0 to 7 of F. So math 9, 0 to 7 of 100 t squared sine root t. Close parentheses for the sine. Throw the x in there. Okay, so 8,263, round your answer to the nearest gallon, gallons. For 0 to 7, find the time intervals in which the amount of water in the tank is decreasing. All right, so again, let's just talk about the total in the tank would equal our initial plus our total that's come in minus our total that's gone out. So our initial 5,000, the total in would be integral from 0 to t of my rate in. Total out would be the integral from 0 to t of my rate out, which is g, which changes. So I'll just like leave it as g, but we can talk about that. That means the rate of change, which is going to figure out when I'm decreasing, will be f minus g. Okay, f is the curve, g is the line. F minus g is going to be negative when g is larger than f. G is larger than f from 0 to 1.617, and g is also then larger than f from 3 to 5.076. So that's when the rate out is larger than the rate in. That's going to be when I'm decreasing. So that's 3 to 5.076. Okay. At what time is the amount of water in the tank to the greatest? Compute this amount of water and justify your answer. Okay, so T is going to be a max and a relative max, which is T prime goes from positive to negative. Or an endpoint. Let's look at signs of T prime. I got 0, I got 1.617, I got 3, and I got 5.076, and I go till 7. Okay, so we got multiple changes, okay? So G is bigger than F, so that's when we're decreasing, so T prime is negative. Then T prime is positive, so I'm adding more from here to here. And then T prime is negative from there to there, just like I talked about. And then T prime is positive. So I have candidates here. So first of all, T of 0 is not, T of 0 could be the max actually. Really, it could be either this, because I go down. It could be this, which is a relative max. It could be 7. This is a situation where all candidates are in play. I end up going up to get to 7. I have a relative max here, and I start out by going down. So we have to compare the values of the candidates. So first, I got T of 0. I got that 500. Is it 500 or 5,000? Gosh, I hope it's 5,000. Well, whatever. It doesn't matter here. The initial amount, 5,000. Its derivative would still be 0. So sorry about that. So 5,000. Great. That's a candidate. Let's find T of 3. That would be 5,000 plus integral from 0 to 3 of F minus the integral from 0 to 3 of G. G from 0 to 3, you're using 250. Let's find that value using our calculator. Why do I keep writing 500? I don't know. 5,000 plus integral from 0 to 3 of F. Find the area under F will be the total increase. minus, you don't have to do an integral here. You could just do 250 times 3, but whatever, let's use an integral. This is the rate out. I get 5,126.590. Okay, so immediately t of 0 is gone. But let's look at t of 7. You know what I'm going to do? And I could do this, and you don't have to do this. I'm almost done. Your initial amount could be the amount at time 3. This actually makes things a little bit easier. You could go just initial amount and then 0 to 7, and then 0 to 3, and then 3 to 7. But watch, the initial amount is this plus my total in starting at our initial amount minus my total out. This helps eliminate using 2 integrals. All of a sudden, I could do that. And like, let's just look at if this is accurate, watch what happens, okay? The area here would be the amount that I lost. The area here is the amount that I've added. So I ended up adding more than I lost, which is why I have more here than here, okay? So I did lose some, but then I added some. But then here, this area, that'd be the total amount that I would lose. That's a lot. And then the end point, it looks like I'm going to add less than I lose. My guess is that this value, and this is without doing any calculations, just by looking at areas, my guess is that the value is going to be less. So watch, this value is my initial amount plus integral from 3 to 7 of f minus integral from 3 to 7 of 2,000. Guarantee you I've lost more than I've added because that 2,000, yep, and I have. This is 4,513. It was a candidate. You can't just like say like I looked at the areas. Like that's not gonna fly. You don't know that this is an accurate model, that the scales are gonna help you understand the differences in the areas, but you know, maybe it gives you a good idea that this is gonna have to be the winner. This is definitely going to be the absolute max T, and because in this case I compared candidates, so this is by the candidates test. Okay, all right, that's it. There is your homework. 2 videos, just split it over 2 days. Thank you.